What if I told you that one of the most basic things you learned in school is something even the greatest physicists couldn't truly explain? Magnets. You've seen them your whole life. They attract, they repel. It feels simple. But when someone once asked Richard Feynman a very innocent question, why do magnets work? He didn't answer it. Not because he didn't know physics, but because the question itself was deeper than it looked. We all think we understand magnets. Opposites attract, like poles repel. Simple, right? But that's not an explanation. That's just a description of what happens. It's like saying objects fall because they fall. It doesn't actually explain why. And that's exactly the trap most of us fall into. When Feynman was asked this question, he didn't jump into equations or scientific jargon. Instead, he pointed out something uncomfortable. Every explanation you give eventually relies on something you don't explain. If you say magnets work because of electromagnetism, then what is a field? If you say it's due to moving charges, then why do moving charges create forces? At some point, you hit a wall. Yes, physics can describe magnets. At a deeper level, magnets work because of something called electromagnetism, one of the four fundamental forces of the universe. Inside atoms, tiny charged particles are moving and spinning. This motion creates magnetic effects. In certain materials, like iron, these tiny magnetic effects line up, and suddenly you get a magnet. But here's the problem. This still doesn't answer the original question. Because now the question becomes, why does electromagnetism exist? Why do charges interact the way they do? Why does the universe even have these rules? And that's where physics stops explaining and starts describing reality as it is. Feynman's genius wasn't just in knowing physics, it was in knowing the limits of knowledge. He said that trying to explain magnets in terms of something more familiar is actually impossible, because magnets are already part of the most fundamental layer of reality. There's nothing more basic to compare them to. We always want explanations in terms of things we already understand. But what if some things in the universe don't have a deeper why? What if they are just the rules? Not everything can be reduced further. At some point, nature simply says, "This is how it works." Think about it. You're holding a magnet in your hand. It's pulling another object through empty space. No wires, no contact, just an invisible interaction. And even today, the deepest theories of physics describe it beautifully, but don't explain why it exists at all. And magnets are not special in this way. Gravity is the same. Why do objects attract each other? We have equations, we can predict it perfectly, but why does mass curve space-time? No one truly knows. So the next time you see a magnet, don't just think of it as a simple object. Think of it as a reminder that even the most ordinary things can hide the deepest mysteries of the universe. And maybe the real question isn't why do magnets work, but how much of reality do we actually understand?